name is Karthiban and my register number is URK23AI1014 and today's experiment number is number 5, which is RNN. The first task is to build a RNN for time series prediction. First we import necessary libraries, which is NumPy TensorFlow and simple RNN for creating RNN model and dense layer, min-max scaler for scaling. Next is to load a time series data, which is a synthetic data. So we include it artificially here, which included amplitude 1, amplitude 2, and noise, which consists of random noise. The data consists of amplitude 1, amplitude 2, and noise. Next step is to pre-process the data by converting it into a 2D array, which which the min-max scaler only accepts the 2D arrays. Next step is to use the min-max scaler. Min-max scaler, it changes the array to a distribution of 0 to 1. And next, to create sequence for the RNN, the sequence length is 20. And next step is to build an RNN model. We use a simple RNN layer which has the activation layer of ReLU and a dense layer. Next step is to compile the model using Adam optimizer, and the loss function used here is the mean squared error and mean absolute error. Next to train the model using a 20 epochs and a batch size of 32. Next, evaluate the model using a mean absolute error and mean square error. Visualize it and see it in the output. Thus, this is the epochs 20 and our test loss is 0.009, which is pretty good. And the mean absolute error is 0.0237. This is the graph for the actual and the predicted output, which is good, and our task is completed. Our next is to build a car sales prediction using RNN. We use the same process here. We use a synthetic data for the car sales and we pre-process the data using a min-max scaler and reshaping it into a 2D array and passing it to the min-max scaler. Here we are using a sequence length equal to 10. Next, using that synthetic sequence layer to build the RNN model, which includes a sequential layer, simple RNN with an activation function of ReLU. Next, we compile the model using Adam optimizer, same as the previous prediction. We train the model and evaluate. Let's see this is the output for the actual sales and the predicted sales. Next is to build a stock prediction using RNN. Stock prediction basically consists of a ticker symbol which denotes the company's identity, and next a starting sale and the ending sale for a day, in which a company starts with a sale at the morning, which is a start date, and the end date is the ending, the closing price of the company. We use a synthetic data for stock price predictions. We use that data we pre-process to a range of 0 to 1 using a min-max scaler. Same, we create a sequence for the input to the RNN model. Here we use a sequence length of 60, which denotes the past days to consider for prediction. Stock price always involves the days which we use for the prediction. Next, we build the RNN model. First, we denote the sequential layer, and then we add a simple RNN which has an active function ReLU, and again a simple RNN layer and which consists and also a dense layer. Next, we compile and train the model And let's evaluate and visualize the results. This is the stock price prediction, the actual and the predicted stock price. The test loss here is 0.008. The test mean absolute error is 0.0216. Thank you.